Hi, everybody, and welcome to a world where glowing rocks once lit up bathroom cabinets. Toothpaste sparkled with deadly charm, and people genuinely thought radiation might help you live longer. Imagine a soft, green glow under your pillow, not from a nightlight, but from the radioactive paint on your alarm clock. The air hums faintly, your fingers trace the outline of something that feels too alive for a mineral, and you think, is this magic? Spoiler, it's not. It's ionizing radiation, and you probably won't survive this. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And I'd love to know, where are you watching from and what time is it for you? Type it down below. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're walking through a dusty old shop, one of those antique ones with the faint smell of mothballs and mystery. Tucked in a wooden drawer is a small pocket watch. Looks ordinary until you notice the hands are glowing. Not from a battery, not from LEDs. This glow is old and very much still radioactive. Welcome to the age of radium, the superstar element of the early 1900s. When it was first isolated by Marie and Pierre Curie in 1898, radium quickly became a glowing sensation. Quite literally, the element emitted a soft, greenish light, which people found utterly enchanting. No one really worried about what the glow meant. It was pretty, and that was enough. Soon, companies figured out they could mix radium with phosphorescent paint and slap it on everything. Watch dials, clock faces, even aircraft instrument panels during World War I. You could check the time in the middle of the night without flicking on a lamp. Convenient, right? Until you realize it came at a terrible price. Let's pause there for a sensory detail. Imagine flicking your wrist in bed at midnight, seeing the green hands of your wristwatch ticking gently, not knowing that every glance was giving you a tiny dose of radiation. Cozy. Radium's appeal didn't stop with watches. People, being people, decided to rub it on their skin. There were radium creams, radium water, even radium condoms. Yes. Seriously, advertisements promised that radium made your skin smoother, your muscles stronger, and your everything more energetic. You'd be practically immortal. Or, glow into the grave. Historians still argue whether these companies truly believed radium was safe or just ignored the mounting evidence for profit. Some early studies, quietly buried, had shown jawbone decay and blood issues in workers. But hey, that didn't sell bottles. One of the most infamous products? Radioactive, a radioactive tonic bottled in sleek vials, marketed as a cure for everything from arthritis to impotence. It was literally distilled radium in water. One particularly enthusiastic drinker, wealthy industrialist Eben Byers, chugged a few bottles a day for years. He swore it made him feel incredible, until parts of his jaw disintegrated and he died a slow, painful death. The press later reported, the radium water worked fine until his jaw came off. A line you probably weren't expecting tonight. But there's a weird, beautiful irony in how humanity first fell in love with radiation. At a time when electricity and industry were transforming life, radium seemed like a miracle from the future, a little glow you could carry in your pocket. This love affair with radioactive substances wasn't born from ignorance alone. It was also rooted in genuine wonder. Think of it, a rock that glows on its own, no fire, no wires. In a world without neon signs or smartphones, that would have felt like witchcraft with a Nobel Prize. And here's your quirky tidbit. Some upscale spas actually offered radium baths, soaking in radioactive water to rejuvenate the skin and recharge your life force. People paid big bucks for the privilege. Can you imagine dipping into a glowing green tub while a man in a tux hands you cucumber water? Of course, modern radiation safety would have a meltdown over that idea. But at the time, these experiences were marketed like today's essential oils, just with, ionizing particles. Your great-grandparents might have owned a glowing clock or even brushed their teeth with radium paste. And strangely, many of these items still glow today, though now they're labeled as hazardous collectibles. The scary part? We didn't just stumble into danger. We dove in head first, dazzled by the shimmer. We humans have a habit of falling in love with things we don't understand, like fire, or fame, or in this case, radioactive decay. And the glow? It wasn't just physical. It symbolized modernity, magic, progress. The same way LEDs and touch screens captivate us now. Radium once made people gasp. You're lying there now, thinking about that pocket watch in the dusty drawer. Still glowing, still ticking, still radioactive. After all these years, and in the distance, beneath the hum of your fan, maybe you can almost hear it whispering, I was beautiful once. You step into a dim, echoey laboratory in late 19th century Paris. Dust motes hover in the slant of sunlight through tall windows, and everywhere you look, glass tubes, heavy notebooks, mineral samples. It smells faintly of ozone, old wood, and a kind of cold excitement. You spot her, a small woman in a dark dress, hunched over a workbench, her fingers stained from chemicals, her eyes wide with quiet awe. This is Marie Curie, and she's falling in love. Not with a person, although she's already married to Pierre, her scientific partner and intellectual equal. No, she's head over heels for a strange, glowing substance they've just managed to isolate from a mountain of pitchblende ore. It's radium, and it shines like stardust in the dark. You watch her stir thick, black sludge in giant cauldrons, reducing mountains of raw material into mere pinpricks of radioactive purity. It's grueling, dangerous, and breathtakingly obsessive. For every gram of radium, tons of or had be processed. Marie doesn't flinch. Her obsession is total. You might call it love, or madness. And here's a haunting fact. Marie Curie's original notebooks are still too radioactive to touch safely. Over a century later, they're stored in lead-lined boxes, and researchers must wear protective gear just to examine them. Her glow was earned. Historians still argue whether Marie truly understood how dangerous her work was. She often carried test tubes of glowing material in her pockets, fascinated by the eerie shimmer. But there were no radiation detectors, no safety standards, only curiosity and a deep belief in the scientific unknown. What's especially curious is how tactile her love of radium was. She didn't just study it. She felt it, carried it, breathed it in. It was like a forbidden romance between a human and a star. And if you're wondering how Pierre felt about all this, he was equally enchanted. Together, they coined the term radioactivity. Their work won 2 Nobel Prizes, one for physics, one for chemistry. They made the invisible visible, the untouchable tangible. But here's your quirky tidbit. Marie once described radium as beautiful in the dark, like fairy light. She was so moved by its glow that she ignored its heat, its burn, its bite. Radium doesn't sting like acid. It haunts from within, a slow, silent kind of death. You might be lying in bed now, thinking she must have been a little extreme. And maybe she was. But think about this. How often do we chase things that shine, even when they're clearly dangerous? Fame, love, power, they don't glow green, but they can still poison you if you hold them too tightly. Marie Curie didn't live in fear of radiation. She embraced it, worked with it daily, wrote about it, slept beside it, and eventually it killed her. Officially, it was aplastic anemia, a disease of the bone marrow. But you don't have to be a doctor to connect the dots. Years of exposure, no protection, and an unwavering obsession with a substance that emits particles like tiny bullets. And yet, there's no bitterness in her legacy, only reverence. Her ashes were buried in the Pantheon in Paris, the first woman to be honored there for her own achievements. And her discovery? It didn't end with watches or toothpaste. Radium opened doors. It led to radiation therapy for cancer. It taught us about the atom's power. It changed everything. We wouldn't have nuclear energy or nuclear weapons without her work. Here's the reality check. You probably wouldn't survive working 1 hour in Marie's lab, but she did it for decades, and she never stopped glowing. So picture her now, walking through a foggy Paris street, her coat pockets gently shining. Not from LEDs, not from magic, but from the very heart of matter itself. Some people leave behind photos or letters. Marie Curie left behind a glow that hasn't dimmed in over 100 years. As you rest your head a little deeper into your pillow, you start to realize her story isn't just about science. It's about obsession, about love for something so pure and mysterious it defies safety, logic, or reason. Because when something calls to you from the shadows, glowing like it knows your name, sometimes you answer. You're in a factory now, not the loud, clanging kind with robots and warning sirens, but a quieter, more intimate place. Rows of women sit at long wooden tables, heads bent in concentration, their white aprons dotted with paint. There's laughter, a radio playing softly in the background, and a strange brightness in the air. Not metaphorical, literal. Each girl dips a thin brush into a small pot of greenish-white paint. Then, with practiced ease, she paints tiny glowing numbers on a watch dials. To keep the brush tips fine, they lick them between strokes, a technique called lip pointing. Over and over. Paint. Lick. Paint. Lick. You feel your stomach tighten. These are the Radium Girls, young women working in dial painting factories in the 1910s and 1920s. The job is considered classy and high-paying for its time. Some of the girls even go out after work, their dresses faintly glowing in the dark from tiny flecks of radium dust. It becomes a trend, wearing your glow like a badge of glamour. They don't know they're swallowing poison. At first, nothing seems wrong. Maybe a sore jaw here, a little fatigue there. But then the symptoms come. Teeth falling out, jawbones rotting from the inside, a strange crunching when chewing. Doctors are baffled. Employers deny responsibility. And the girls, still so young, are dying. Historians still argue whether the companies truly believed the paint was harmless or just pretended not to know. What's clear is that once the effects became obvious, the cover-up began. Executives refused medical care, dismissed symptoms as hysteria, hid reports, blamed the workers. But these girls didn't go quietly. Several fought back, risking shame and blacklisting to sue the corporations that poisoned them. In a time when women couldn't even vote in some states, they took their cases to court and won. Barely, slowly, often after their own deaths. You shift under your blanket, maybe picturing one of them, Molly, Grace, Hazel, young women with dreams, with futures, who simply took a job to help their families and ended up glowing in coffins lined with lead. And yet, there's something oddly beautiful about the way they lit up the night. Here's your quirky tidbit. Some of the girls painted their nails and teeth with radium paint for dates, believing the glow made them more attractive in the dark. Imagine kissing someone and seeing their smile light up like a flashlight. And here's the scientific kicker. The radium they ingested settled in their bones, mimicking calcium. The body welcomed it, tucked it into its deepest places, not knowing it had invited a traitor inside. That's why their jaws were among the first things to collapse. Even today, decades later, their graves still emit small traces of radiation. The girls are still glowing, in a way. You might feel a little chilled now, not from fear, but from a strange kind of reverence. Because in fighting for justice, the Radium Girls helped establish labor safety laws, radiation exposure guidelines, and the foundation of modern occupational health. They changed the rules, even as they faded. Now imagine one of them sitting on a rooftop with her friends after a long day at work. She laughs, leans back, her dress softly glowing. She doesn't know she's dying. None of them do. In that moment, they feel alive, modern, beautiful, futuristic. That glow, once a promise of magic, was really a warning. But the world didn't listen in time. We don't always know when something we love is killing us. Sometimes it tastes sweet. Sometimes it shines. You glance at your wristwatch, probably digital, probably safe, and realize how far we've come. But part of you still wonders, if you saw a glowing dial in a thrift shop, would you be tempted? Just one touch. You're walking through a quiet laboratory again, this time in Germany, 1938. There's a hum in the air that feels different. Not electric, exactly more like tension. Scientists huddle over a heavy table with flasks and lead shielding, eyes narrowed, hands steady. And then it happens. A uranium atom splits. It doesn't shatter dramatically or scream in a comic book style boom. No, this is smaller, quieter. More chilling. One atom becomes two, and with that fission, it releases energy. More energy than anyone expected. And now you're staring at the ghost inside the atom. This moment, nuclear fission, wasn't just a physics experiment. It was a door. And once opened, it changed the world forever. Historians still argue whether Otto Hahn, Lise Meitner, and their colleagues truly grasped what they'd unleashed that day. They were just exploring the nature of matter, after all. But like drilling a hole in a dam wall, the implications started rushing out faster than they could patch them. You've probably heard the term splitting the atom, but you may not have felt its weight. Here's the reality. When uranium atoms are split, the reaction releases millions of times more energy than a chemical explosion. It's the difference between lighting a match and detonating a star. This wasn't just scientific progress. This was Pandora's box with an instruction manual. And what happened next? The race. The nuclear arms race. Scientists across the globe began building on that moment, fearful that others were building faster. It became not just a question of discovery, but one of survival. You lie back, thinking about that. How curiosity, unchecked, can become a weapon. All because someone asked, what if we poke it a little harder? Here's your quirky fact. The early atomic scientists used bathtubs and buckets to test nuclear chain reactions. One misstep, and they could have irradiated the entire lab, or themselves. They called it tickling the dragon's tail, which, if you're keeping track, is probably something not to do. And yet, like kids with firecrackers, they pushed forward. Fascinated, nervous, in love with their creation. There's something beautifully contradictory about radiation. It's invisible, but inescapable. Silent, but devastating. It hides in particles too small to see. And yet it has the power to flatten cities. And you, yes, you, are slightly radioactive too. Just from living. From the sun, the soil, even the bananas you eat. Think about that. A banana gives off measurable radiation. Not enough to hurt you, unless you hoard them like a potassium-obsessed dragon. But it's there, inside you. Now imagine a time before Geiger counters, before shielding, before even knowing that atoms had parts. Scientists were like blindfolded explorers in a room full of live wires. And they touched everything. And here's the philosophical piece. Nuclear fission showed us that at the very core of matter lies chaos and power, the kind that powers stars, the kind that ends wars. And it raised questions we still struggle with today. Should we have discovered this? Should we use it? Can we ever trust ourselves with it? Because while some saw the atom as the key to energy independence, others saw it as a loaded gun pointed at humanity's own head. You sink into your pillow a little deeper now, thinking about how something so small, an atom, can be split and spun into politics, fear, electricity, bombs, and breakthroughs. That's the thing about radiation. It doesn't care how you use it. It just does what it does. Unleashes. Remember that glow in the watch dial? Multiply that by trillions. That's the glow inside a fission reaction. And when it gets out of control, well, we'll get to that in a few sections. For now, just picture the silence after that first atom split. One scientist setting down his pipette, another holding her breath. The future rushing in like a tidal wave. You're sitting in a pastel-colored kitchen. The wallpaper has tiny ducks on it. The refrigerator hums gently, and a metal lunchbox with a rocket ship sits on the counter. It's the 1950s in American suburbia, where everything seems safe, structured, and serene, except for the looming possibility of atomic annihilation. The world has just seen what nuclear weapons can do. Hiroshima and Nagasaki aren't distant rumors. They're real, burned into the global psyche. And now, in the quiet calm of post-war domestic life, people are trying to figure out how to live with that knowledge. So they build bunkers. Not military bunkers, backyard ones. Under the lawn, beside the swing set. A steel trapdoor leads to a concrete room with canned peaches, a portable toilet, and a hand-crank radio. Your family practices duck and cover drills. At school, you crawl under your desk as if wood and chewing gum could protect you from a nuclear blast. Historians still argue whether these drills provided any real protection or just the illusion of control. But in a time when the sky could flash white without warning, People needed to feel like they had a plan, even if that plan was essentially curl up and hope for the best. Here's your quirky tidbit. Some families held atomic parties in their bunkers, test runs where everyone stayed underground for a weekend. Board games, jello, and lots of awkward silence. You might laugh, but imagine being 10 years old, brushing your teeth by flashlight while your parents whisper upstairs about radiation clouds and fallout patterns. That hum of the refrigerator becomes eerie. That lunchbox becomes a survival kit. And yet people adapted. They bought radiation detectors for the home. Read guides like How to Survive a Nuclear War. Suburban dads took pride in their fallout shelters the same way others bragged about new barbecues. Mine seats 12 and has a backup generator. But underneath it all, fear. A low, constant dread that the world could end in a flash. And what's wild is that people kept living anyway. They watered the lawn, watched game shows, painted nursery walls, all with the quiet understanding that it could all be vaporized tomorrow. There's something incredibly human about that. We're excellent at ignoring doom when it's inconvenient. We joke about it, turn it into drills, dress it up with mid-century furniture and canned goods. You shift in bed, maybe glancing at your window, wondering what it would feel like to see a mushroom cloud on the horizon. Not from a sci-fi movie, but for real. Would you run? Would you freeze? Or would you calmly head to your fallout shelter with your tuna cans and transistor radio? That's what people in the 1950s had to ask themselves. And most of them just shrugged and made meatloaf. But this fear also shaped an entire generation. It birthed movies about giant ants, aliens mutated by radiation, and superheroes born from nuclear accidents. Radiation became a storytelling device, both villain and miracle maker. You either died from it or became stronger. Sometimes both. And the government? Oh, it leaned into the drama. There were public service films, cheerful announcers explaining how to identify fallout or purify contaminated water. One even featured a cartoon turtle named Bert who demonstrated how to duck and cover, as if the Cold War were just another episode of Sesame Street. It would be funny if it weren't real. Here's the truth. The threat of nuclear war became domestic. It moved into the living room, onto cereal boxes, into bedtime prayers. And somehow, people still found ways to fall asleep. Just like you're doing now. Maybe wondering if your great-grandparents ever sat in a bunker with a flashlight, whispering about the end of the world. Maybe they did. Maybe they passed down that quiet resilience, the ability to smile through dread, to turn danger into routine. Maybe that's why we're still here. You're browsing a drugstore in 1920s, the kind with creaky wooden floors and tall glass cabinets filled with potions, powders, and promises. The lighting is soft, the air smells faintly of soap and alcohol, and every other label seems to boast some kind of miracle. Weight loss, hair growth, eternal youth. And then your eyes land on a sleek little bottle with a glowing label. Radioactive, certified radioactive water. Yes, radioactive water. Welcome to the era when radiation wasn't just tolerated. It was marketed as a cure-all. This wasn't some fringe health fad whispered about in alleyways. It was mainstream, sold by respectable doctors, advertised in newspapers, and swallowed by businessmen, athletes, and even royalty. A little radiation, they said, would boost your vitality, rev up your metabolism, reignite your sex drive. The logic? If radiation could kill bad cells, maybe it could just energize your good ones. Historians still argue whether these claims were based on genuine misunderstandings or straight-up pseudoscience. The truth probably lies somewhere in between. Early studies did show radiation could kill tumors, but they didn't yet understand how precise that application had to be. Too much, and you weren't healing. You were slowly cooking from the inside. But nuance never sold products. Here's your quirky tidbit. Some companies infused chocolate bars and butter with radioactive thorium or radium. You could literally eat radiation for dessert. There are also radioactive suppositories, which you don't want to picture, but now you are. Sorry. You lie there blinking in the dark, maybe trying to imagine the kind of confidence it took to pitch this idea with a straight face. Drink this glowing water. It'll make you stronger. And people believed it. Not because they were foolish, but because science was booming. Electricity had transformed homes. Chemistry cured disease. Why shouldn't radiation give you superpowers? One of the most famous casualties of this radioactive craze was Eben Byers, a wealthy American socialite who drank multiple bottles of Radioactive a day. For years, he raved about how youthful and vigorous he felt, until, of course, his jaw disintegrated. His skull literally began falling apart. At his death, the newspaper headline read, "The radium water worked fine until his jaw came off." You can't make this stuff up, and still, companies kept selling it. Radiation toothpaste, radiation facial creams, even a radioactive corset for back pain. If it glowed, it was gold. The cultural obsession went beyond the medicine cabinet. There were radium-themed dances, songs, even perfumes. The glow of modernity, they called it. People didn't just tolerate radiation, they wanted to bathe in it. Literally, some spas offered radioactive baths, where you could soak your bones in mineral-rich, irradiated spring water. Sound familiar? Yeah, it's like a Marvel origin story, but more lawsuits. And here's a fun sensory image for you. Imagine sipping warm tea from a uranium glass teacup. Yes, the cup itself is slightly radioactive. These glowing green dishes were common in homes well into the 1940s. Some still exist today, safely tucked into antique cabinets, still gently ticking with radiation. Now, of course, we know better. We understand radiation's double-edged nature, its ability to heal and harm. But in that golden age of glowing cures, nobody wanted to hear about limits or risks. They wanted a miracle, preferably one that sparkled. The irony? Some of the ideas weren't totally wrong, just wildly unregulated. Today, we do use radiation in medicine. In controlled, precise doses, radiation helps shrink tumors, sterilize equipment, even diagnose diseases. But back then, it was like handing out flamethrowers in a kindergarten and calling it innovation. You roll over, letting that image settle. A world where toothpaste glowed, water buzzed, and every medicine bottle hummed with invisible energy. The faith people had in progress. The risks they took with their own bodies. The price they didn't realize they were paying. And maybe you start to see a pattern. We humans are suckers for the shiny new thing. We want a shortcut, the secret, the glow. Even if it means swallowing something we can't pronounce. Even if it means glowing a little on the inside. You're 8 years old, curled up on a shaggy carpet in front of a wood-paneled television. It's Saturday morning, and between cartoon marathons and cereal ads, something catches your eye. A shiny, colorful commercial flashes across the screen. The Atomic Energy Lab. Now with real uranium ore. Wait, what? Yes. In a golden era of toy innovation, nestled between Slinkies and chemistry kits, you could buy a toy set that came with actual radioactive materials. Welcome to the strange and glowing world of atomic toys for kids. The most famous of these was the Gilbert U-238 Atomic Energy Lab, released in the early 1950s. It wasn't some cheap plastic thing either. This was a full-blown science kit complete with cloud chambers, Geiger counters, radioactive rocks, and a detailed guide on how to observe atomic behavior safely. It promised to teach young minds the wonders of atomic energy. You know, like radiation decay, particle tracking, and the slow sizzling of household safety. Historians still argue whether the kit was a noble attempt at public science education or a marketing stunt gone radioactive. The fact that it was discontinued after just 1 year suggests that parents might have raised a few glowing eyebrows. Here's your quirky tidbit. The instruction manual actually encouraged kids to wave the Geiger counter near the family cat to detect background radiation. Because nothing says fun weekend like using your pet as a science experiment. And this wasn't the only atomic-themed toy. You had glow-in-the-dark yo-yos, radioactive slime, and board games like the nuclear war card game, where players competed to launch missiles and destroy cities. Fun for the whole family. But it wasn't just toys, it was culture. Schools ran Nuclear Science Week events. Kids drew mushroom clouds in crayon. Even comic books were filled with radioactive origin stories. Spider-Man, Hulk, the X-Men, all born from radiation accidents. Radiation wasn't a threat. It was the ultimate plot device. You lie in bed, picturing a kid in 1954 mixing glowing powder in a basement, mom yelling from upstairs to come wash for dinner. He's not worried. Why would he be? The box said it was educational. And to be fair, some of these kids did grow up to become physicists, scientists, engineers, maybe even the people who designed the safety standards we now rely on. But still a toy with uranium? That's the magic and madness of the atomic age. When science leaped so far ahead of regulation that you could buy nuclear-themed breakfast cereal with tiny glow-in-the-dark prizes inside. And here's the chilling part. These toys weren't recalled for being radioactive. They were discontinued mostly because they were expensive or just didn't sell well enough. Safety concerns didn't even make the top 5 reasons. You could say parents were more worried about price tags than particle decay. It wasn't until years later, as understanding of radiation's dangers deepened, that people began quietly removing these items from homes. Kits disappeared into basements. Uranium samples were confiscated by the government, and the glow faded. But they're still out there. A few lucky, or unlucky, collectors have tracked down working sets. Carefully stored, heavily monitored, occasionally displayed at science museums behind thick glass and stern warning signs. Imagine stumbling across one at a garage sale. A dusty box labeled Atomic Energy Lab. Do you open it? Touch it? Sell it on eBay? Or maybe you just back away slowly? Because here's the truth. The line between learning and danger has always been blurry, especially when wrapped in shiny packaging and sold to kids. And now you're drifting, just a little, picturing a simpler time, of bubblegum and mushroom clouds, of children playing science with glowing stones, of a world too enchanted by its discoveries to worry about side effects. Not evil, not careless, just dazzled. You're in a dense forest in Central Africa, in a place that looks untouched, ancient, even. The air is warm, the earth a rich red-brown, and the ground beneath your feet crunches with centuries of silence. You kneel beside a rocky slope, looking at chunks of grayish stone. Nothing unusual at first glance. But what you're standing on is a nuclear reactor. Not a man-made one, a natural one, and it's been here for nearly 2 billion years. Welcome to Oklo, in Gabon, West Africa. This is where, long before humans ever split an atom, nature did it first. Discovered in 1972, Oklo puzzled scientists at first. A team was examining uranium ore from the region when they noticed something strange. The uranium-235 levels were lower than expected. That's the type of uranium used in nuclear reactors. So where had it gone? Turns out, it had already been used. Naturally. Here's your quirky tidbit. Over 1.5 billion years ago, the exact conditions at Oklo, uranium concentration, groundwater, rock formations, came together like puzzle pieces, triggering a self-sustaining nuclear chain reaction. In other words, Earth built a reactor, fired it up, and kept it running for hundreds of thousands of years. And it did it without supervision. No engineers, no control rods, no safety committee. Historians and geologists and physicists still argue about how rare this is, whether Oklo is a once-in-a-universe accident or something that could happen again under just the right conditions. You lie there now, eyes closed, and maybe you're imagining it. Deep beneath ancient soil, a silent fire flickering, pulsing through uranium veins, whispering energy into the crust. Long before dinosaurs, long before language, before the very idea of a nuclear age existed. And somehow it didn't explode. Instead, the natural reactor at Oklo ran in short bursts, like a candle flickering on and off. It would heat up, the water would boil away, the reaction would stop. Then groundwater would seep back in, and the process would start again. On, off, for hundreds of thousands of years. You know what's wild? It regulated itself. Something we struggle with even in modern engineering. Nature just figured it out. It's humbling, isn't it? We like to think we invented nuclear energy. But the truth is we rediscovered it, copied it, refined it, and maybe misunderstood it. This ancient reactor also changed how we think about nuclear waste. When scientists studied the byproducts of Oklo's reaction, They discovered that the radioactive elements hadn't moved much at all. They stayed locked in the rock for billions of years. That gave modern scientists hope that, with the right geology, we might safely store our own nuclear waste, too. Of course, it's still a subject of intense debate. There are no guarantees when you're talking about waste that needs to stay contained for longer than human civilization has even existed. But still, nature did it once. Maybe it's not impossible. There's something poetic about Oklo. It reminds us that the universe doesn't wait for us to understand it before it does its thing. That power, unseen, unstoppable, moves through rock, water, time, and space, whether we're ready or not. You breathe a little slower now, imagining a gentle, glowing reaction chamber hidden deep beneath the earth. A flickering reminder that the energy we seek has always been there. We just had to dig deep enough to find it. And now we try to control it, to harness it, to store it. But nature? Nature just let it burn, long before we knew what it was. You might wonder, what other secrets lie buried beneath our feet, still humming softly, waiting for us to notice? You're standing at the edge of a wide, quiet river. It's 1986 in the Soviet Union. The air is still, unnaturally still, and across the water rises a concrete structure surrounded by scaffolding and silence. The trees are green, the sky is pale, and everything feels wrong. You're looking at Chernobyl. The name alone sends a chill. It doesn't explode in your ears like nuclear bomb or mushroom cloud. Instead, it seeps in. It's the sound of silence gone radioactive. This is the site of the world's most infamous nuclear accident, when reactor number 4 at the Chernobyl nuclear power plant exploded, releasing radioactive materials into the air for days. It wasn't a bomb. It wasn't war. It was human error, wrapped in secrecy, made worse by a failed safety test and too much confidence. Historians still argue whether the Soviet design was fatally flawed or whether the catastrophe was avoidable if procedures had been followed. In reality, it was a perfect storm of design limitations, rushed experiments, and a culture of denial. It began with a late-night safety test, ironically, meant to prevent future disasters. But the test spiraled out of control. Power dipped dangerously low, and operators tried to correct it using methods that violated their own safety protocols. Then, in a move that now feels like horror fiction, they disabled the automatic shutdown systems. What followed was a runaway reaction, a series of explosions, and the release of more radiation than both atomic bombs dropped on Japan combined. Here's your quirky tidbit. The graphite moderator used in Chernobyl's reactor core burned for 9 days, spewing radioactive ash across Europe. The wind carried cesium and iodine across borders, turning the accident into a global event. In Sweden, thousands of kilometers away, workers at a nuclear plant first detected the radiation, before the Soviets even admitted anything was wrong. Now imagine the town nearby, Pripyat, a model Soviet city full of young families, amusement parks, schools. No alarms, no warnings, just a strange metallic taste in the air, blue flashes in the night, and soldiers with Geiger counters showing up without explanation. Children played outside as radiation levels skyrocketed. You sink deeper into your pillow as you picture it. A playground with empty swings. A Ferris wheel that never turned on. Abandoned dolls on school floors. Pripyat was evacuated too late, and too quickly. People left everything behind. Many never returned. Chernobyl wasn't just an environmental disaster. It was a psychological scar. It exposed cracks not just in reactor walls, but in government systems, trust, and the idea that science could be perfectly controlled. And it changed everything. Nuclear safety standards were overhauled. Power plant designs were reconsidered. Countries re-examined their own facilities with a sudden, uneasy urgency. Even now, the area around Chernobyl is a ghost zone. Some call it a radiation safari, where you can tour abandoned villages and see nature reclaiming the land. Stray dogs roam the streets. Forests have crept into old buildings. And somewhere beneath a concrete shell, the remains of reactor 4 still simmer. Not active, but not exactly safe. You might wonder, lying there in the dark, How could something designed for light and power go so wrong? And that's the paradox of radiation. It's a tool, a miracle, a monster. When it works, it powers cities. When it fails, it makes them vanish. Chernobyl was a reminder that when we dance with the atom, we don't always lead. But here's something softer to hold on to. Despite the tragedy, the zone is now one of the most unexpected wildlife refuges on Earth. Wolves, boars, birds, even bears, all thriving in a place humans fled. The land, though poisoned, began to breathe again. Nature doesn't forgive, exactly, but it adapts. Quietly, slowly, with glowing moss and fox tracks in the dust. And maybe that's the lesson here. Even in the aftermath of our worst mistakes, life finds a way to flicker back. You're floating now, metaphorically, in deep space. Everything is quiet, endless. Below you spins a tiny blue and white marble, Earth. And beside you, tethered to a sleek, silver craft, is a metal cylinder no larger than a basketball. It's humming gently, emitting invisible heat. Inside it, plutonium-238. This is no weapon. It's a radioisotope thermoelectric generator, an RTG. And it's the reason humanity can explore the outer solar system. Here's the twist. After centuries of fearing radiation, we found a way to make it our deep space companion. Solar panels work fine for satellites near Earth. But once you pass Mars, sunlight becomes too weak. If you want to send probes into the icy reaches of space, past Jupiter, Saturn, Neptune, you need a reliable power source. And nothing works better than a lump of radioactive material that stays hot for decades. RTGs don't explode. They don't glow ominously. They quietly convert heat from radioactive decay into electricity. Steady, predictable, dependable. Here's your quirky tidbit. Every Voyager probe, still sailing through interstellar space since 1977, runs on radioactive power. So do Curiosity and Perseverance, the rovers trundling across Mars. Even the Apollo lunar missions left RTGs on the moon, still gently pulsing warmth into the silence. Historians still argue whether it was reckless or brilliant to launch nuclear material into space. After all, what if the rocket exploded during takeoff? The U.S. government prepared elaborate contingency plans in case radioactive dust scattered over Florida. But the missions went forward and succeeded. You lie there in bed, imagining a lonely robot billions of kilometers away, powered by something dangerous yet life-giving. A nuclear heart beating in the dark. There's something poetic about that. The very thing we once feared as death became the breath of distant machines. Radiation, used carefully, has become the pulse of exploration. It doesn't need light. It doesn't care about temperature. It just keeps ticking, like a cosmic campfire. And there's more. RTGs aren't the only nuclear tech we send into space. Engineers are now developing nuclear thermal propulsion, rockets powered by small fission reactions that could shorten travel time to Mars and beyond. Because when you want to cross the vast nothingness faster, splitting atoms still gives you the best bang for your buck. Of course, the idea of carrying reactors into space still makes some people nervous. Memories of Chernobyl and Cold War paranoia haven't faded. But the math, the engineering, the containment systems, they're solid. Safer now than ever. So we press on. Because we always do. You glance toward your window, imagining Voyager I, now farther from Earth than any object we've ever made. Still sending faint signals. Still powered by a decaying core of plutonium. The atoms inside that core were forged in a lab. But their ancestors were born in supernovae, exploding stars. Every radioactive element we've ever used is a whisper from the cosmos, now returning to it through machines of our own making. And that's what's beautiful. Radiation is not just danger. It's connection between life and death, between power and stillness, between Earth and the stars. It's easy to forget, under our fluorescent lights and LED screens, that we still rely on these silent forces, that we owe our knowledge of Saturn's rings, Pluto's ice plains, and Mars's red dust to radioactive heat drifting through cold voids. So next time you look at a NASA photo or a rover selfie on another planet, Remember, somewhere inside that machine, a tiny piece of radioactive matter is glowing softly, not to harm but to help, to light the path, to power the journey, to keep curiosity alive. You're standing in a dim hospital hallway now. The floor is clean, the air is sharp with disinfectant, and somewhere down the corridor, a machine hums like a sleeping dragon. You turn a corner and see it, a bulky, ring-shaped device, futuristic and familiar all at once. A technician adjusts the controls. A patient lies still, breathing gently beneath a blanket. This is radiation in its most intimate form. Not in war, not in space, but in the fight for survival. Cancer treatment, medical imaging, healing through controlled exposure. Radiation, once feared as a destroyer, is now a lifeline. The journey wasn't smooth. In the early 20th century, radiation therapy was more like guesswork with glowing tools. X-rays were discovered in 1895, and just months later, doctors began using them, without knowing how much was too much. Some patients got better. Others developed burns, hair loss, or worse. Still, it was a start. Historians still argue whether early radiation therapy was brave medicine or reckless experimentation. Probably both. Here's your quirky tidbit. Some doctors in the 1910s believed standing in front of an X-ray machine boosted general health, like sunbathing. One even recommended X-ray exposure for baldness. Spoiler, it didn't grow hair, but it did cause other things to fall out. But over time, we learned. Machines improved. Math improved. So did humility. Today, radiation therapy is precise, guided by scans, simulations, and targeted beams. It kills cancer cells while sparing healthy ones. It's not magic, it's physics in service of biology. You lie there now, the word radiation sounding less ominous. Maybe you're thinking of someone you know who's had an MRI, or a CT scan, or gone through weeks of radiation therapy. Those aren't rare stories, they're all around us. And that's the paradox. The same forces that light up stars and destroy cities can also save lives. It all depends on intention and control. Modern hospitals use machines like linear accelerators, which fire beams of electrons or photons with such precision that they can treat tumors the size of a pea. The process is painless, quiet, and terrifyingly powerful. Patients lie still, covered in tiny tattoos that guide the targeting systems. Sometimes they listen to music. Sometimes they fall asleep. And after the treatment ends, most patients walk out, go home, and wait. Because the healing isn't instant. It's invisible, slow, molecular. But it's real. Still, there are risks. Radiation doesn't discriminate. Even today, treatment comes with side effects. Fatigue, nausea, burns. Some worry about long-term consequences, damage to nearby tissues, new cancers years later. It's not perfect. It never was. But when it works, it gives people more time. More birthdays. More breakfasts and bike rides and bedtime stories. And that's no small thing. You might picture a child sitting in a hospital gown, clutching a stuffed animal. A mother waiting outside the lead-shielded door. A technician whispering through an intercom. Just hold still, sweetheart. Almost done. And the machine hums, and the child stays brave, and the invisible beams do their work. That's radiation too. Not the monster. Not the glow-in-the-dark horror. But the quiet helper, calibrated down to the millimeter, doing what it can to push back the dark. And even beyond cancer treatment, radiation helps us understand our bodies. PET scans, bone density tests, nuclear medicine tracers. All of them rely on tiny doses of radioactive materials that reveal what the eye can't see. Blockages, bleeding, activity, the flickering map of life beneath the skin. Radiation lets us see inside ourselves. It also reminds us that fear can evolve. What once terrified the public has become routine. And maybe, just maybe, we're learning how to use power without being consumed by it. So the next time someone says radiation, maybe you won't flinch. Maybe you'll remember the machines, the doctors, the patients. The software of healing behind heavy doors. Because sometimes the same force that burns can also save. You're in an airport security line now. The fluorescent lights buzz overhead, and people shuffle forward with laptops in bins and keys in pockets. A uniformed agent gestures toward a sleek archway ahead. You step through, and somewhere nearby, radiation scans your body. Don't panic, it's not dangerous. This is radiation for detection, for security, for safety. Another place where invisible energy watches over us in the background. You probably don't think about it much, but low-level radiation technologies have become part of your daily life. Airport scanners, smoke detectors, cargo inspections, even food sterilization. All made possible by that same mysterious force once feared and worshipped in equal measure. Here's your quirky tidbit. Your smoke detector likely contains a small amount of americium-241, a synthetic radioactive element. When smoke enters the chamber, it disrupts the radioactive particle flow, triggering the alarm. Radiation saves thousands of lives a year just by quietly waiting on your ceiling. Historians still argue whether widespread radiation use in consumer devices was introduced too quickly before long-term effects were fully known. But so far, the science is clear. The levels in these devices are so low, they pose virtually no risk. Still, the idea of being scanned by radiation can feel unsettling. After all, we've seen the movies. Mutants, secret experiments, glowing test subjects. But here in real life, you walk through a millimeter wave scanner, and the machine forms a harmless image to check for hidden items. Or maybe your checked luggage goes through X-ray machines, where radiation briefly illuminates the objects inside. You might be surprised to know that even your bananas in Brazil nuts emit small amounts of natural radiation. In fact, you absorb more radiation on a single airplane flight due to cosmic rays than from passing through a scanner. You lie there in the quiet now, thinking about all the ways radiation flows invisibly through your life. The security line, the microwave sterilizing your sponge, the medical isotopes tracing your blood flow during a heart scan. It's not an enemy. It's a tool threaded into modern society like copper in your wiring. But detection goes beyond airports and kitchens. Governments and scientists use radiation detectors to monitor nuclear activity worldwide. Devices called spectrometers and dosimeters sniff the air and soil for radioactive isotopes. If a country tests a bomb, the world knows. If a reactor leaks, satellites pick it up. After the Chernobyl disaster, radioactive clouds drifted across Europe. But the fallout was mapped quickly, not by sight, but by radiation tracking systems hidden in labs, universities, and military posts around the world. Even some animals get involved. In certain regions, butterflies and birds are monitored for radioactive uptake, giving early warning signs of contamination. Nature becomes the Geiger counter. There's also the black market side of radiation. Yes, it exists. Authorities around the world track attempts to smuggle radioactive materials, often for profit, occasionally for malicious purposes. It's rare, but it happens. And radiation detection is our first and best defense. Still, most radiation detection is mundane, quiet, routine. It happens in labs and factories and shipping docks. Thousands of workers wear radiation badges on their uniforms, tiny plastic squares that change color if exposed. Not dramatic, just vigilant. And that's what radiation safety really is now. Not fear, but monitoring. Quiet awareness. A whisper in the background reminding us that invisible forces are real and controllable. You might recall the old Cold War propaganda, the grainy film's warning of invisible death rays, radioactive fog, mutant vegetables. And yet today, we coexist with radiation daily, calmly, confidently. It's no longer a mystery. It's a measurement. And maybe that's the most reassuring thing of all. Because when you measure something, you understand it. When you understand it, you can live with it. And when you can live with it, well, maybe it isn't a monster after all. You're in a dark cave now. No, deeper than that. Miles underground. The walls are made of ancient rock, undisturbed for hundreds of millions of years. It's cold. Still, the only sound is a distant drip of water echoing through stone. And somewhere nearby, nuclear waste is asleep. This is not science fiction. This is the reality of nuclear storage, the final chapter in radiation's journey. Because for all the ways we use radiation to heal, to explore, to power, the truth is it leaves a trace. Spent fuel rods, reactor byproducts, medical isotopes, radioactive waste that stays dangerous for thousands, even millions of years. So where do you put it? You can't just bury it in the backyard. You can't launch it into space. Too risky. And you definitely can't just flush it down the drain. So, around the world, governments have turned to one solution: deep geological repositories. Imagine a vault, hundreds of meters below the surface, carved into stable bedrock. No water seepage, no earthquakes. Just layer upon layer of engineered barriers, steel casks, clay buffers, and reinforced tunnels. The idea is simple: seal the danger away and let time do the rest. Historians still argue whether we'll ever build a perfect nuclear tomb, one that lasts longer than any civilization, one that remains safe even if future societies forget it's there. And here's your quirky tidbit. Scientists are working with linguists and artists to design warnings that could survive 10,000 years or more. Not just signs in English or Chinese, but symbols so universal that even a far future species might understand. Do not dig here. This is not treasure. This is death. Some designs resemble thorns. Others use towering obelisks or eerie landscapes, structures meant to feel wrong, to tap into primal fear. Because language fades, but instinct might endure. And you lie there now, picturing a world long after ours. The city's gone, the satellite's silent. But beneath the ground, the waste remains, still ticking, still dangerous. A whisper from our age of power, waiting to be forgotten. It's a haunting thought, but also a responsible one. Because here's the thing: nuclear waste is not an accident. It's the bill we pay for the energy, the medicine, the space probes. And like all debts, it demands an answer. So we build vaults. We mark the maps. We train engineers. Not because we expect to be thanked, but because it's the right thing to do. Some waste, like low-level hospital material, becomes safe in a matter of years. But high-level waste, like spent reactor fuel, glows with danger for millennia. It needs deep time, the kind of time our species barely understands. You might wonder, will someone someday stumble upon it? Mistake it for a tomb or a temple? Dig it open, not out of malice, but curiosity? That's why the design of these repositories is as much psychology as it is engineering. How do you convince a creature you've never met, in a language you've never heard, to stay away forever? The answer may be, you can't. But you try anyway. You build the deepest holes. You add the most redundant layers. You write the warnings in 1,000 tongues. And then you trust. Not blindly, not naively, but with care. Because radiation, for all its danger, isn't malicious. It's just energy released by nature, harnessed by humans, returned to the earth with as much wisdom as we can muster. And maybe, as you drift closer to sleep, you realize that this story of radiation isn't just about science. It's about stewardship, about holding something powerful, using it wisely, and letting it go carefully when its time has passed. The light fades, the chamber closes, the silence deepens, and the waste sleeps on. You're walking through an art museum now, quiet, hushed, the kind with tall ceilings and soft lighting. Your footsteps echo faintly as you move past oil paintings, ancient pottery, sculptures chipped by centuries. But then you stop in front of something unexpected, a display glowing softly under ultraviolet light, marked with a warning sign. It's not the art that's dangerous. It's the radiation inside it. Welcome to one of radiation's most unexpected homes. Culture, antiques, museums, even fashion. For over a century, humans have infused radioactive materials into everyday beauty, sometimes on purpose, sometimes by accident, and many of those objects still exist today. Here's your quirky tidbit. In the early 1900s, women applied radium-infused face creams and powders to achieve a healthy glow. And they got one, just not the kind they were expecting. You lie in bed, eyebrows slightly raised. Radioactive makeup? Yes. And that's just the start. Take uranium glass, also known as Vaseline glass, a soft green-yellow material that glows under UV light due to trace amounts of uranium oxide. It was wildly popular in the late 19th and early 20th centuries, used in everything from teacups to candlesticks. Many people still collect it today. Safe, mostly, but still radioactive. Historians still argue whether these artifacts should be displayed, stored, or destroyed. Most emit very low levels of radiation, but the idea of invisible danger sitting behind museum case gives some curators and visitors pause. And the strangest part? These pieces aren't just relics of ignorance. Some were made after we understood radiation. For example, certain 1950s watches used radium paint on the hands and numbers so they'd glow in the dark. So did clocks, aircraft instruments, even some military compasses. That glow, once seen as the height of innovation, came at a cost. You might have heard of the Radium Girls, young women hired in the 1910s and 20s to paint glow-in-the-dark numbers on watch dials. They were told it was harmless, even encouraged to lick their brushes to make a finer point. The women began to suffer mysterious illnesses: jaw pain, tooth loss, fragile bones. They were accused of being hysterical. But eventually, their deaths led to workplace safety reforms and widespread recognition of radiation's long-term effects. Their story is tragic, but also heroic, because they fought back, filed lawsuits, and forced companies to acknowledge the dangers. In doing so, they changed the world. Their courage echoes in every lab coat and workplace safety manual today. And yet, even now, echoes of that glowing obsession linger. Some collectors still buy vintage watches with tritium or promethium-147, later replacement for radium. Safer, but still radioactive. Others keep uranium-glazed ceramics on shelves. Even Fiestaware, the famous red-orange dishes, used uranium in its glaze until the mid-20th century. Beautiful? Absolutely. But your soup might hum a little more than expected. You shift under your blanket, imagining a dinner table in 1940, every place setting glowing faintly in the dark. The idea of danger wasn't even part of the equation. It was about style, novelty, prestige. Radiation had become fashionable, and not just in objects. The very idea of radioactivity crept into films, novels, advertising. Comic books glowed with origin stories of radioactive spiders and mutant powers. Radiation was danger, yes, but also transformation. It was the nuclear sublime, terrifying and beautiful all at once. You might wonder how many radioactive things you've walked past without realizing. A museum vase, a compass at a flea market, a glowing button in an old airplane. Most are harmless now, but they carry stories. They remind us that science isn't always in a lab. It's in our culture, our closets, our memories. And maybe that's what makes it so fascinating. Radiation isn't just numbers on a Geiger counter. It's woven through history, invisible, powerful, misunderstood, and occasionally fashionable. So next time you see something glowing in the dark, ask yourself, is it just clever lighting? Or is it something older, deeper, still softly buzzing with the echoes of another era? You're walking alone now, through a quiet field, just after sunset. The grass glows faintly silver in the moonlight. There's no wind, just the hush of crickets and the steady pulse of your breath. Somewhere nearby, unseen but ever present, are traces of radiation. Not from power plant, not from a bomb, but from the Earth itself. Because here's a truth most people never quite realize. You live surrounded by radiation every single day. It's in the rocks beneath your feet, the air you breathe, the food you eat, even inside your body. Potassium-40 in bananas. Radon gas in basements. Cosmic rays from stars that died long before your ancestors had names. Radiation isn't rare. It's natural, ubiquitous, eternal. You might be surprised to learn that the average person receives more radiation each year from natural sources than from any man-made one. Your morning coffee, a walk in the mountains, even living at higher altitudes gives you a slightly higher dose. Here's your quirky tidbit. Airline pilots and flight attendants are technically classified as radiation workers because they spend so much time at cruising altitude, exposed to cosmic rays. A transatlantic flight gives you a dose equivalent to a chest X-ray. Every time, historians still argue whether this background radiation subtly influences evolution, fueling random mutations that drive natural selection. We may never know for sure, but it's clear that life, from its very beginning, has grown up in a radioactive environment. And you're built to handle it. Your DNA is constantly under assault from sunlight, chemicals, and yes, radiation, but your cells repair themselves with astonishing efficiency. Most of the time, you never notice. Radiation, it turns out, is not an intruder. It's a condition of existence. Of course, thresholds matter. Intensity matters. Too much radiation overwhelms those repair systems. That's when things go wrong. Cancer, sickness, long-term damage. But most of the time, we walk through a radioactive world like fish through water, barely noticing, always adapting. There's something deeply humbling about that. You're not just surviving in spite of radiation. You're surviving with it, alongside it, within it. And maybe, lying there now, listening to the soft white noise of night, you realize how strange and beautiful that is. This invisible force that can burn cities, heal bodies, power spacecraft, and etch itself into our bones is also just part of life. We fear it, we revere it, we regulate it, but we never truly escape it. Even the stars owe their glow to nuclear fusion, atoms slamming together, releasing energy that drifts through space, across time, and lands gently on your skin as warmth. And in the end, perhaps that's the quiet lesson of radiation. That power doesn't have to be loud. That danger can be a teacher. That light can be both gift and warning. So tonight, as you let yourself fade, think about the world beneath your mattress, behind your walls, beyond your sky. Think of the isotopes humming softly in old rocks, of Voyager still whispering from the void, of the Radium Girls, the Mars rovers, the hospital machines, the cave vaults, the ghost town playgrounds, the uranium teacups, the atoms drifting through your very blood. You are a child of radiation, and somehow, you're still glowing.